Now there's one other thing that I can do, and that is to put all of them together. All three of these laws, if we combine them together, we see that volume times pressure, and if we take the volume divided by the temperature and the volume divided by the moles, that will give us some constant. So if we write that, we have the volume divided by moles, that's Avogadro's law. We have the volume times the pressure, that's Boyle's law. And we have volume divided by temperature, that is Charles' law. This is equal to a constant. And this time I'm going to write the constant as R, because this is what we call the ideal gas law. When we combine Avogadro's, Charles, and Boyle's law together, we get the ideal gas law. Okay. Typically, we write this. We can take these two, multiply both sides by that, and we get like I say, typically we write the pressure first and the volume. Of course, mathematically it's the same, but PV equals nRT. This is the typical format that we express the ideal gas law in. Okay, so here we have the pressure, we have the volume, and then N is the moles. T, of course, is temperature. And then R is what we call the ideal gas constant. All right. So we still have that constant just like we did before, except this time we will include it in our final equation. All right. So PV equals nRT. Definitely want to remember this. Right. And also, all of the other laws, since this is a combination of Avogadro's law, Boyle's law, and Charles' law, you can derive them all from this. So really you don't have to remember each of those individual ones. You can just remember this, and then you say, okay, if I'm not changing the moles and I'm not changing the temperature, then that means all of this is a constant, right? Because this isn't changing, that's not changing, R is a constant, so all of that would be a constant, which means P1 V1 equals P2 V2. On the other hand, if I'm not changing volume or moles, but I am changing the temperature, then I can put everything that's a constant on one side and everything that's changing on the other side, and I would end up with pressure, and I would divide by the temperature equals, and then N would be constant, R would be constant, and I would divide by the volume. That would be some constant, okay? But I'd have pressure over temperature. Right? We didn't show that relationship, but this would hold as well. Changing the pressure versus the temperature. Okay, but this is Boyle's law, and then we have Charles' law would be if we held pressure constant and moles constant. We put all those together, you have volume divided by temperature. Just solving that equation for putting everything that is constant on one side. So all of this is my constant. So that means V1 over T1 equals V2 over T2. Okay, and this is Charles' law. This is Boyle's law, Charles' law. You just need to remember Boyle's law relates volume to pressure. Charles' law relates volume to temperature. And Avogadro's law is where I'm changing moles and volume. So V divided by N, pushing P, which would be held constant, RT over P, that would all be a constant, V over N, or V1 over N1 equals V2 over N2. All right, so Avogadro's law with the moles, Charles' law with temperature, and Boyle's law with pressure. All right, all of these based on and derived from the ideal gas law. So it can simplify the memorization. PV equals nRT, and in the case of the combined one, where we're not talking about either any one of those individually, but putting Boyle's and Charles' law together, we would have PV divided by temperature, everything that's changing on one side, and then everything that's constant, N and R would be held constant. That would be on the other side, since it's constant. P1 V1 over T1 equals P2 V2 over T2. Same thing, all based off of PV equals nRT. Okay, so just remember this. Remember pressure, volume, and temperature. Those are pretty obvious. N is moles. R is the ideal gas constant, and the value for the ideal gas constant is 0.0821, and it has units of liters times atmospheres per moles times Kelvin. So there's our pressure. Atmospheres is pressure times volume, and then moles times temperature, right? Just from that equation. Okay. If we had different pressure units, then our value would be different. And sometimes you will see R expressed with different units. So it's important to know what units you have. Okay. It's very important. Liters times atmospheres divided by moles times Kelvin. It's important to associate those units with your number, because you will often see R expressed. It's actually often expressed in terms of joules per mole Kelvin, in which case it's a different value. Okay. Now the temperature must always be in absolute units. That's what we use Kelvin for, because there's no negative temperature for Kelvin. We couldn't use Celsius or Fahrenheit for this because it won't work. You know, if you put 0 Celsius, you don't have, just because it's freezing, it doesn't mean that there's no volume or pressure. Okay, so we have to use absolute temperature units, which are Kelvin. That's what we typically use. Okay.